question 2b here. So we got to solve for y again. Notice this one has an initial value. Y of 1 is 5, so that means we're going to have to solve for our c at some point. We'll hold on to that for a little bit and do the integration so that we can get to our c spot. Go ahead and deal with this first. So the first thing I got to do is I got to decide what method I'm using. Typically, we want to look to see if something's linear or separable first. If you look at this, t times y prime plus 2 times y equals t. You know, this is just a y. It's not squared or anything like it was in the last time. And then this is also just a y prime. It's not squared. It's not inside of a sign or anything like that. And the t doesn't change that. The t, we're allowed to have that there. So this actually falls into the category of being linear. So we're going to use integrating factor, or a mu. The first thing we need to do is normalize. In order to normalize, I got to divide by t on both sides. I got to have the y prime by itself. So if I do that, I wind up getting y prime plus, I like to write 2 over t times y equals, when I divide by t on this right side, I get 1. From there, you know, the letter that we use for this function is often p. So mu, my multiplier, that's why it's mu, is e to the integral of p of t dt, which in this case is e to the integral of 2 over t dt. That is going to give me, all right, integrate 2 over t. I'm actually going to pull the 2 out front. So I'm going to get e to the 2, and then I'm going to write ln, absolute value of t, because the 1 over t dt integrates to an ln. Then I'm going to plug it. So I'm going to pop this guy in here. So I get e to the ln of t squared. And the absolute values don't matter here, partially because it's a squared, but also because it just doesn't matter as we're doing this e to the. And then from there, the e to the and the ln cancel, and I get a t squared out. So that's going to be my multiplier. I'm going to take this guy and multiply it on all sides, or on all terms of this equation up here. And then I'm going to be able to undo the mess on the left side. So that gives me t squared y prime. When I multiply this piece right here by t squared, I wind up getting plus 2 times t times y, because it cancels with that, the t cancels with the t in the bottom there in the denominator. Equals, don't forget to multiply this piece right here by t squared as well. Sometimes people do that, skip that spot. So I get t squared there. A lot of times if you forget there, you wind up in some like crazy integration by parts problem. So if you're doing really wacky integration by parts, look back and see if you missed that step. All right, so now you should know that this derives to that. So the y derives to the y prime, and the t squared derives to the 2t. So what's that tell us? This and this are the two pieces of the reverse product rule that we've talked about in terms of integrating factor. So I'm going to get t squared times y prime, because you could check it. If you were to derive this, because it's multiplication there, okay, you would get this back out. So writing it as t squared times y primed is equivalent to what I have on this left side right here. All right, so let's keep going. I'm going to go back to blue. Is equal to, the right-hand side doesn't change. I just rewrote the left-hand side. So from there, I'm going to integrate both sides. Integrate. On the left side, when I integrate, the integral cancels with the prime. So I get t squared times y, just because they're opposite operations, integral and derivative. Equals, I don't have that on the right side. We can write dt if we want. Integrate that with respect to time. I get 1/3 t cubed. And this is where you have to remember to put your plus c there. All right, so what were the initial conditions? Y of 1 is 5. So I'm going to write y of 1 is equal to 5. I'm going to use that now to solve for my c. This is sometimes the best spot to solve for the c. Sometimes you want to wait till a little bit later, but typically we want to do it here. So, all right, so this is the y value, y equals 5, and this is the t value, t equals 1. So I'm going to plug that into all these spots, all the different spots in this equation, and figure out what c is. So when I do the 5, I get 5 squared times 1. And then that gives me equal to 1/3 times, oh, whoops, I did that backwards. Come on. Did you catch that? T is 1, so I get 1 squared times 5 equals 1/3 times 1 cubed. Sorry about that mistake. Plus c. So that gives me 5 equals 1/3 plus c. If you think about 5, it's really 15/3, so I can do some arithmetic with fractions and get that c is equal to 14 divided by 3. In my class, I always use a calculator for that, but you should still be able to do it by hand. So from there, our last step is to just, our second to last step is to combine these two and get t squared y equals 1/3 t cubed plus 14 divided by 3. So the final step is to solve for y, have a y equals form, because that's typically what we're looking for. What is y given a particular time? Couldn't do that in the last question, but we can in this one, so we do it. So all I do is divide by t squared. If I do that, I get y equals, divide the first term by t squared, I just get 1/3 t, because t squared into t cubed gives me t. And then plus, I'm going to write this as 14/3t squared. You could write it in a variety of ways, but I typically like to have positive exponents when I can. I'll put things in the same fraction when I don't simplify, but this one simplifies well, so I'm going to leave it like that. So that's our answer. Hopefully you're feeling okay with the integrating factor, the mu substitution, or the mu multiplier, and we'll go on to the next one.